Hi everyone. We are going to start with introduction to probability theory. Just a second. Introduction to probability theory. Here we'll be discussing about population, sample space. Also, we'll talk about data. We'll talk about different types of data and histograms. And using these two, data and histogram, we will try to learn and construct uh, uh, information about the population using the sample space. So today we'll be discussing about this. So in this lesson, our primary focus is to get a bigger picture of the entire course that lies ahead of us. And along the way, we'll also learn some basic concept that will help us to begin and build our probability toolbox. So let's see why probability is in use and where its application lies. So, for example, research studies are done. So let's take a research study. Research studies are conducted in order to answer some kind of questions, right? For example, researcher in Mumbai define at least 8 primary questions that they would like to answer about the health of the people who ate entirely animal-free diet. There is no meat, no dairy, and no eggs. Another research study was recently conducted to determine whether the people who take the painkiller, the pain medicines, are at a higher risk for heart attack than people who don't take them. So there can be plenty of questions. Like the question could be what percentage of the college students feel sleep deprived? What is the probability that the randomly selected St. Stephen's student gets more than 7 hours of sleep each night? And do women typically cry more than men? So there can be many questions, assuming that the all the questions are of our interest. So the question arises over here is how can we answer our research questions if we cannot ask every person in the population, then how will we answer the questions? So we could take a random sample from the population, and here comes the application that we will be discussing about is about the random sample. So if we have to understand, first of all, we have to understand what is a random sample, right? So let's talk about first of all, in trying to answer each of our research question, we fortunately can't ask every person in the population. Instead, we take a random sample from a population and use the resulting sample to learn something and make inference about. So where this random sample works, like let's see, there is a population. Let's say there is a population and we take sampling. We'll discuss what is sampling, and this is the sample, that is the data. And now we draw inference about the data, and using this inference we try to get the information about the population, the characteristics traits that we want about the population, right? So the main thing is, what is a random sample? Random sample is the smallest unit that is taken from the population in order to understand the behavior of the population. The random sample that we take, we try to maximize the number of different categories of people that could be uh, that could be taken in the random sample. right? Now, using this random sampling, that was sample is sampling that we take. And what is a sample? So sample is defined with the term sample space. Sample space is said as the sample space is the collection of all the possible outcomes of a random study, right? So let's try the definition that sample space is the collection of all the possible outcomes of a random study, right? So in order to answer our first question, that was, do people feel sleep deprived? So the question, if the question is, do people feel sleep deprived? So in order to answer this question, the sample space could be yes or no, right? This could be the example. Now, if we can also take an example, like if we are talking about that, uh, how many student had, uh, the number of hour of sleep that they had last night. The student, how many student had, sorry, we are exactly trying to find the number of hours of sleep that the students had last night. So in that case, if H denotes the R, the sample space is denoted by capital S or some or omega. So we are denoting with the S. So S will be set as H such that H is greater than equal to 0 R, right? So this could be the sample space. Another example is, how many days did you cry last month? Right? How many days did you cry last month? So question could be, how many days do you cry last month? Uh, did you cry last month? So the answer will be 0, 1, 2, 3, could be at max 13, right? So this could be the probably how many cries that they had. So we are actually trying to obtain an answer to a research question. So for each of the research question we created, we try to formulate some question. And using that question, we define the resulting sample space. So once we collect the sample data, we need to do something with it. Uh, in order to obtain some information about the data, about the population, we have collected the sample data. And now we need to do something with the data, like summarizing could be the option. And summarizing totally depends upon the type of data we collect. So the next thing that we will understand is the sample data. Also can be termed as a qualitative data that we have collected. Now, this is divided into basically three categories. That is, first is discrete, the second is continuous, and the third is categorical. Right? Under categorical, we have seen the binary data. We'll see the binary data. Now, to start with the discrete, continuous, and categorical data, the main purpose of studying the data is to summarize the responses and try to find the information about the population. So let's define the discrete data, right? Discrete data. So discrete data is defined as the qualitative data which is discrete in nature if condition for this is if the sample contains a finite or countably infinite number of values, right? So let's recall the set of elements are countably infinite if the element in the set can be put to one-to-one correspondence with the positive integer, right? So our question, this question, where we discussed how many days did you cry last month? So in this section, what this question, if we have to discuss this question, so under this, we find the sample space to be 0, 1, 2, 3, dot, 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 up to 31, right? So it contains a finite number of values, and this is called countably infinite number of values. Sorry, a finite number of values. And what is countably infinite number of values? Like the question could be, if we try to understand the condition for the sample space, if we look at how many credit cards do you have, right? If the question is how many credit cards do you have? So for finite, we have seen the uh, number of days you cried in last month. For this, the sample space was 0, 1, 2, up to 30, right? For countably infinite, if we see the question is the number of credit cards do you have, or the other question could be the number of books do you have. So for both of the questions, the sample space could be 0, 1, 2, 3, up to an finite number that is countably, but it is infinite, right? So what we saw about discrete is it has to be finite, the sample has to be finite or countably infinite, right? Now we'll see continuous data. How to define the continuous data? The continuous data, the qualitative data are called continuous if the sample space, we are going to play with the sample space, right? Sample state contains an interval, right? Or continuous span of real number. So our second research question that was how many hours of sleep do the student had last night? Uh, example, if we talk about the number of hours of sleep student had last night, the sample space will be what? X X has to be greater than equal to 0 hours. Maybe someone has not slept also. So this could be a particular example. So here, if we see, it is the entirely positive real line. For a continuous data, there is a theory that an infinite number of a possible outcome is possible. The measurement tool, the measurement tool here is the restricting factor. By restricting factor, I mean, for example, if I were to ask how many each of the student in the class weighed in pounds we are talking, I would mostly like to get a response such as 126 pounds, 172, 210. So if I ask someone that how many student in the class weighed, so how much does each of the student weigh in the class? So it could be 206, 122, 210. The responses are similarly discrete. The responses are seemingly discrete. But are they discrete? If I report that the weight is 118 pounds, am I exactly 118 pounds? Probably not. I am perhaps 118 point, let's say 0, 1, 2, 3, 4. It's just that the scale that I get on in the morning tells me that I weigh 118 pounds. Again, the measurement tool here is restricting factor. What we are restricting is something we always have to think about when trying to distinguish between the discrete and continuous is restricting factor, right? Now, the third is the categorical data. Now, to understand categorical data, like this, like if we have to define the categorical data. The quantitative data are called categorical if the sample space contains objects that are grouped or categorized based on some qualitative trait, right? When there are only two groups or categories, the data are considered to be binary. So we had earlier seen that under the categorical data, there is a subpart called as binary. So if we have to define is, so if the sample space contains objects that are grouped, right, or categorized, the name itself says categorized based on some qualitative traits, right? So if we look at the first question that we discussed here, let me show you. The first question, that do people feel sleep deprived? This was our first question. Do people feel sleep deprived? So our answer will be, either yes or no. For example, if it is asked, do people sleep deprived? So for this, the sample will be yes or no, right? So in this case, the sample space has been categorized into two groups, yes group and a no group. And when the sample space is categorized into two groups or category, obviously, they are called binary. And this is what we were talking about, the binary data, right? So the other examples of categorical data in general, this was an example of binary data, that how many of you feels, do people feel sleep deprived or not? The other question could be the color of eye. Color of eye. That could be black, brown, blue, depending upon. So so this could be categorized in brown, blue, even hazel is a color. So if we are talking about the semester standings, that is, do I mean by semester standing is semester standing. Semester standing. That is the category in which we will differentiate, and the college students could be freshmen. They can be sophomores. They can be junior and senior. So this is the different type of data. Now, since we have collected the sample data, we need to utilize this data in some or the other manner to get the information about the population. So in next class, we will discuss how to use this sample data to get information about the population. So we'll learn the tools that are required to interpret and to get the inference one of the tool that we will be discussing in the next class will be histogram, right? Histogram. So let me brief you about the histogram a bit. That histogram is of basically three types, you can say. There is frequency histogram. The second will be the what we call it density histogram. Basically, it is of two type, and then there is a histogram that is called relative histogram. That it will be done in comparison with this frequency histogram. There we will also discuss about mean, median, and mode. So later part, not basically mean, but we will be discussing about mode. Let's see. In next class, we will discuss all of this. So how to summarize the qualitative data graphically. So histogram is a graphical tool for this purpose. Thank you so much. We will discuss it in our next class. Right.